Good morning, ladies and gentlemen. Today we're going to be talking about linear inequalities and moving into systems of linear inequalities. What is a linear inequality? Well, a linear inequality is something that is similar to a linear equation. It will look very familiar. But in place of the equal sign, you will have a less than sign, or a greater than sign, or a less than or equal to sign, or a greater than or equal to sign. So it has an inequality symbol in place of the equal sign. We will pretend it has an equal sign to graph it, and then we'll do something else. So get your colored pencils ready. I like this lesson because we get to color. What are the solutions to a linear inequality? I know the question says what is the solution, but there are infinite solutions. To a linear inequality, and that's what we'll use our colored pencils to show. So the solutions are going to be all the ordered pairs that make the inequality true. I'm running out of space. Okay, so here's an example. Determine which of these ordered pairs are solutions to the linear inequality 2x minus 3y is less than 15. So our ordered pairs are always written x comma y, so I'm going to plug in 2 for x and 5 for y and decide if I have a true statement or not. So I get 2 times 2 minus 3 times 5 is less than 15. 2 times 2 is 4. 3 times 5 is 15. 4 minus 15 is negative 11. Negative 11 is less than 15. So the answer is yes, and this point is a solution to this linear inequality. Let's try another one. 2 times negative 1 minus 3 times negative 7 is less than 15. Negative 2 plus 21 is less than 15. Negative 2 plus 20, 19 is less than 15. False. No. Not a solution. All right, see how this works? 2 times 3 minus 3 times negative 4 is less than 15. 2 times 3 is 6. Negative 3 times negative 4 is positive 12. 6 plus 12, 18 is less than 15. No, not a solution. You have to get a true statement for it to be a solution. 2 times 0 minus 3 times 0 is less than 15. 0 is less than 15, yes. The point 0, 0 is a solution. All right, so we will be graphing linear inequalities, and they will look like this. We will draw a line. We will pretend there's an equal sign and draw the line just like we know how to do. And then we have to figure out which side of the line to do our coloring or our shading on. So we'll start by isolating y, writing the inequality in y equals mx plus b form. And then we will graph the inequality. Now this one is a little bit different because if you have a less than or greater than sign, we will use a dashed line or a dotted line. And if we have an equal bar underneath the inequality, then we will use a solid line. One of the ways to figure out which side of the graph to shade is to use a test point. Pick a point not on the line that we graphed and do what we did just a minute ago. Put it into the inequality and see if you get a true statement. if it's true, then we will color on that line. For example, 0, 0 is in the shaded area here. So if we put 0, 0 into the inequality for this line, we would get a yes, and then we would color on the side of the line that has 0, 0. 0, 0 is the easiest point to use, but it only works if it's not on the line that we graphed. All right, let's try one. Y is greater than 1/3 x minus 5. This is already isolated y, so I can graph this line. There's -5. Slope is 1 over 3, up 1 over 3, up 1 over 3, down 1, left 3, down 1, left 1, 2, 3. Okay. Is this going to be a dotted line or a solid line? This looks like a dotted line to me because there's no equal bar underneath the inequality. And it says y is greater than. So I'm going to put 0, 0 in. So I put 0 in for y, 0 in for x. 0 is greater than -5. That is true. So I will color on the side where 0, 0 is. Okay. Let's try another one. Again, y is already isolated, so I can graph the line. I pretend there's an equal sign there. First point goes at -1. Slope is -2. That means I go down to right 1, down to right 1, up to left 1, up to left 1. Is this going to be a solid line or a dotted line? This one's going to be a solid line because there's an equal bar underneath the inequality. Okay, 0, 0 is just to the right of this line, so I can use 0, 0. 0 is less than or equal to -2 times 0 minus 1. 0 is less than or equal to -1. That's false. So I'm going to color not on the side where 0, 0 is. I'm going to color on the other side. All right. Let's try another one. This time I'm going to have to isolate y. So I subtract 5x from both sides, and I get -2y is greater than -5x plus 12. Divide every term by -2. Y, and what happens when I divide everything by a negative number? I have to switch the sign. Y is less than 5 over 2x minus 6. Did I do that correctly? Okay. Now I'm going to graph the line. Pretend there's an equal sign there. 1, 2, 3, 4, 5. There's -6. Slope is 5 over 2, up 5 over 2, up 5 over 2. Having trouble seeing here. Is this going to be a dotted line or a solid line? This one's going to be a dotted line. Now I have to figure out which side to color on. If I put 0, 0 in, I will get 0 is less than 0 minus 6. 0 is less than -6. That's true. So I'm going to color on this. No, 0 is not less than -6, is it? 0 is, that's a false statement. Oh my goodness. So I'm going to color on the side away from 0, 0. Okay. Number 4, I have to isolate y, so I'm going to subtract x from both sides. -4y is less than or equal to -x plus 8. Once again, I'm dividing everything by a negative number, so I'm going to have to switch that sign again. Y is greater than or equal to 1x over 4 minus 2. All right, I can graph this line. -2 is the y-intercept. I go up 1 over 4, up 1 over 4, down 1 left 4, down 1, left 4. This is going to be a solid line because there's an equal bar underneath the inequality. I can put 0, 0 in. I get 0 is greater than or equal to 0 minus 2. 0 is greater than or equal to 0. 0 is greater than or equal to negative 2. That's true. So I'm going to color on the side where 0, 0 is. Okay. Now comes the fun part. A system of inequalities is two or more of these, two or more linear inequalities. The solution to the system of inequalities is the overlapping region. The overlapping region of points that satisfies both inequalities. All right, so now I have to graph both lines and figure out where they intersect. So I definitely need my colored pencils this time. All right, x plus y is greater than negative 1. Y is greater than negative x minus 1. I just subtracted x from both sides. So I can graph that line, negative 1. Slope is negative 1, down 1, right 1. This is going to be a dotted line. 0 is greater than 0 minus 1. 0 is greater than negative 1. That's true, so I'm coloring above the line. Now I need to get a different color. Isolate y again, subtract x from both sides. I get negative y is greater than negative x plus 5. Divide everything by negative 1. Get y is less than x minus 5. All right, let's see. Y-intercept is negative 5. 1, 2, 3, 4, 5. Is that 5? Slope is 1. Having trouble seeing what I'm doing here. This one's going to be a solid line. Y is less than x minus 5. If I put 0 in, I get 0 is less than negative 5. That is not true. So I'm not going to color on the side of 0, 0. I'm going to color on the other side. And then I'm going to take a third color and double shade the area where I've colored both red and green. That blue area is the solution to the linear inequality. All right, let's try another one. I see this one, y is already isolated, so I can graph this line. Go up 4. Slope is negative 1, so down 1, right 1, down 1, right 1, up 1, left 1. This is going to be a solid line or a dotted line? It looks like a solid line to me. And if I put, yes, I can use 0, 0 this time. 0 is greater than or equal to 0 plus 4. 0 is greater than or equal to 4. That doesn't sound right. So I'm going to be coloring away from 0, 0 on the other side of the line. Looks like the other one I need to isolate y, so I'm going to write negative x plus 3y is less than 21. Add x to both sides. 3y is less than x plus 21. Divide by 3. Y is less than 1/3 x plus 7. All right, 7 is up here somewhere. 1, 2, 3, 4, 5, 6, 7. Slope is 1/3, up 1 over 3, up 1 over 3, down 1, left 3, down 1, left 3, and this is going to be a dotted line. If I put 0, 0 in, I get 0 plus 0 is less than 21. That's true. So I'm going to color on the side where 0, 0 is. That would be this side. And then I'm going to double color where I've colored red and blue. Okay. Number 3. Once again, I have to isolate y, so I'm going to subtract 2x from both sides. I get negative y is greater than or equal to negative 2x minus 1. Divide everything by negative 1, I get y is less than or equal to 2x plus 1. First point is up 1, slope is 2. This looks like a solid line. And I think it's supposed to cross above 0, 0. Well, another way to think about it is if y is less than 2x plus 1, less than means I'm going to color underneath the line. Okay, other one, negative 4y less than or equal to negative x plus 24. Divide by negative 4. You get y is greater than or equal to 1x over 4 minus 6. Slope is up 1 over 4, up 1 over 4, down 1, left 4. This is another solid line. Y is greater than, so I'm coloring above the line this time. And I'm going to double color where I've colored both the black and the red. That's going to be the solution area, that blue. All right, is this making sense? Let's try one more. X is less than negative 4. That's a vertical line. Crosses the x-axis at negative 4. 1, 2, 3, 4. It's going to be a dotted line. Because there's no equal bar. And everything less than negative 4 is to the left of the line. With y, we're thinking up or below. With x, we're thinking left and right. For the other line, I need to isolate y. So I'm going to subtract 3x from both sides. You get 2y is less than or equal to negative 3x minus 2. Divide everything by 2. Y is less than or equal to negative 3 halves x minus 1. So I got negative 1. Slope is negative 3 over 2. It's down 3, right 2. Down 3, right 2. I don't think I did that very, very well. Maybe did. Up 3, left 2. This is going to be a solid line. Y is less than or equal to, I could put 0 is less than or equal to negative 1. All right, so we're going to be coloring underneath this red line. And then I'm going to double color where I've colored with both colors. But it's going to stop right about there. Okay. X is less than 4. That's a vertical line. It's going to be a dotted line. It's supposed to be a line. I'm coloring to the left because the numbers less than 4 are to the left. Y is less than 4. That is going to be a horizontal line. That is also a dotted line. And the numbers less than 4 are underneath. Now I'm going to double color where I've colored with both colors. And that is this square looking area. Alright, you should be pretty good at this by now. Y is less than x minus 4. There's the line, and then I'm coloring underneath. Y is greater than x plus 4. 2, 3, 4. Again, the slope is 1. Dotted line. This time I'm coloring above the line. Uh-oh. There's no overlap. That means there's no solution. Remember, that's going to happen from time to time. All right, here's your U-tries. Number 1, y is less than 3x minus 5. Number 2, y is greater than negative x minus 2. And y is less than or equal to 3x plus 6. And your other U-tries, x minus 4y is greater than or equal to negative 8, and x is less than 2. And a really good one, x is greater than or equal to 3, x is less than or equal to 5, and x plus y is less than 6. See if you can figure that one out. All right, bring your questions to class and bring your colored pencils because we're going to be coloring.